Let's start the discussion. Is my screen visible?
Yes, visible.
Okay. So this is the first question. Uh, Chef's website has a specific response mechanism based on the HTTP status code received. If the response code is 404, the website will return not found. For any other response code different from 404, the website will return found. Okay. So very simple. You will just take input and just respond
हाँ
found or not found. Clear?
हाँ हाँ ठीक है.
Okay, coming to the next question. In chef land, there are X schools and each school has Y students.
Yes.
The year and results are in and a total of Z students passed the exams.
Yes.
Assuming that all students appeared in the exam, find whether the number of students who passed in chef land was strictly greater than 50%. So, okay, it is also very simple. There are
Yes.
X schools and each school has Y students. So these are the total number of students. And uh, then we have to check, we are given Z. So we need to check that this Z into 2 is strictly greater than X into Y, right?
Yes.
So this is very simple, I guess. Here, what we have to do is this should be greater than 50%. If this is strictly greater than 50%, then say this is 50.1%. So 50.1 into 2 will be equal to 100.2. Okay. So even if it is zero point 0.1 extra, it should print yes. Or if it is equal or less, it should print no, right?
Mm.
So
Yes.
even if it is 50%, so 50 into 2 will equal to 100 only.
Yes.
Okay. And 100 is what? Like uh, we are checking for this z into 2 is how much of x into y. So if z is more than half of x into y, then z into 2 will be greater than x into y.
Yes.
So that's the logic with which we are trying here. Let's
Oh.
see some sample test cases, and with it we'll clear the things. Okay, I'll get uh, so here in the first example we have total of 20 students. 12 students have passed. So 12 into 2, 24, which is greater than 20. So yes.
Yes.
Now next we have uh, 3 students. So 3 into 2 is 6. 6 is less than 20. So no.
Yes.
Then again 3 into 2, 6 is greater than 1 into 5. 6 is greater than
Hmm.
5. So yeah, we can say that more than 50% student have passed.
Yes.
Okay. So again here we'll check. Oh sorry. For this we'll check. This is 18 and this is equal to 3 into 6. So again we can say that no, not more than 50% students have passed. Is it clear?
Yes. Yes. Clear.
Okay. So now we'll move to the next problem. You were able to solve these two problems, right?
Yes. Yeah.
Okay. Chef embarks on a journey starting from a town named S, containing a string of 8 uppercase English alphabets. His objective is to reach the destination known as Codetown. If Chef is currently in town, T1, then with each move, chef can transition to another town named T2, provided that either T2 is derived from T1 by replacing a consonant with another consonant, or T2 is derived from T1 by replacing a vowel with another vowel. Okay,
Yes.
so is the question clear?
नहीं, क्वेश्चन ही तो क्लियर नहीं हो पा रहा था.
Okay, no issues. Then we'll go through some of the sample cases and then we'll try to understand the problems. Okay, so here every time we'll be given a string which will have exactly 8 uppercase English characters,
Hmm.
right?
Yes.
So uppercase means capital, okay,
Hmm.
and then chef is currently in town T1, and with each move he can transition to any other town, provided that either T2 is derived from T1 by either replacing a consonant with another consonant, or T2 is replaced from T1 by replacing a vowel with another vowel. Okay. So this, okay, let's take an example and things will become very much clear. So chef wants to reach this place, code town.
Yes.
Okay. So we can see that here the word is an 8 letter word. Okay.
Hmm.
And it is given in the question that we will always be given an 8 letter word only.
Yes.
So here, let's come to the first example. YAPETOWN. So here, what we can do? Like it is given, then it can transition from one town to another if it has a character difference. Either a consonant is replaced by another consonant, or a vowel is replaced by another vowel. Okay.
ये
So,
बताइएगा,
uh,
जैसे कि बोला वन वन टाउन टू अदर, यानी फर्स्ट टाउन इज कोड टाउन एंड सेकंड टाउन इज येप टाउन.
no, no.
ये
First town is Yape Town, and from Yape Town you have to transition to Code Town.
ओके. अच्छा
Okay.
अच्छा. हाँ.
Okay. Or you can think eitherwise also. Otherwise also,
अच्छा.
like you can transition from Code Town to Yape Town also.
हाँ.
Okay. So here what we have? Here we have D. Here we have P. Here
यस.
we have C. Here we have Y. Okay. And
हाँ.
rest. Okay. Here also we have A, and here we have O. So here also we have some difference.
ये डिफरेंसेस क्या मतलब, मैं समझ नहीं पाया. सी एंड वाई, इसमें क्या डिफरेंस है? दोनों तो कॉन्सोनेंट ही में ही आएंगे.
Difference is that the name of the town should be equal. Like here, these two are not equal,
ओके.
right?
हाँ.
So from Y, what we can do is in the next time we can change Y to C. Okay, so it will become Cape Town.
ठीक है.
Okay, and next time we can replace A with O, so it will become Cope Town. And next with we can replace P with D, and it will become Code Town. Is it clear?
यस.
What we were doing? Like one thing is very much required here, that if here we are having a consonant, okay, we our main goal is to reach to Code Town only, right?
यस.
Codetown. Here we are given any random string.
यस.
Okay. So if this is a consonant, this character should also be consonant.
हाँ.
If this is not equal to C, we'll transition it to make it equal to C. That is not the problem. But
ओके.
if it is a consonant here, it should also be a consonant here, right? If it is a vowel here, it should also be a vowel here also. If it's not the case, then we can't reach the destination, which is Codetown. Like here in Codechef, Codechef. Okay,
Okay.
and our destination is Codetown. So here it is consonant, consonant, vowel, vowel, consonant, vowel, consonant, and here it is a consonant, and here it's a vowel. Okay, now we can't change this H, which is a consonant, to a vowel,
Mm,
right?
yes.
We can replace it with another consonant only. So we won't be able to put a vowel here, and if we can't put a vowel, then we can't put O here, and if we can't put O here, then we can't make it town. So I hope it is clear now.
Yeah, yeah.
Sure.
हाँ हाँ.
Okay. Now let's move to the fourth question. You were able to solve this problem, right?
Yes.
Okay. So one thing I would again highly recommend, that the time you get post contest, these 1 2 days prior discussion, you try to spend more time on the questions, on the concepts you were not able to understand in the contest, and then try at least 1 2 hours on each problem which you are not able to solve, at least the
Mm,
next problem which you are not able to solve. Like you were able to solve 4 questions in the last contest, then try at least 2 to 3 hours on the fifth problem. By that way, your rating and your understanding and your problem solving skill overall will increase.
मेरे
So
में एक और प्रॉब्लम क्या है ना कि मैं मतलब 10-15 मिनट ट्राई करता हूँ और मतलब कि ये कॉन्सेप्ट नहीं क्लियर लग रहा है कि अप्रोच ही नहीं मतलब अटेम्प्ट कर पा रहा हूँ, तो मैं डायरेक्ट सॉल्यूशन देख लेता हूँ, इसमें ही मुझे
no, by if you don't spend a lot of time on a problem, you won't get a good grip over the problem. So it's very important to spend quite good time on understanding that problem, solving that problem. Okay.
हाँ.
So now let's come to this problem. You are given a string S of length n. A non-empty string y is considered beautiful if it satisfies both of the given conditions. Let f c of x denotes the frequency of character c in x. For every character c present in a string y, fc of y should be less than fc of s.
Yes.
Okay.
Yes.
So what is given? You are given a string s of length n. A
Mm,
non-empty string y is considered beautiful if it satisfies both of the given condition.
yes.
Okay. Frequency c of x denotes the character frequency of character c in a string s. For every character c present in y, its frequency should be less than or equal to the character present in s. Right?
Yes.
Is this statement clear? If we have c in y, we have got two strings. String one's name is y, string
Mm,
two name is s. So if we have got character c in string y
yes.
and also character c in string s,
Yes.
okay,
Mm,
then frequency of this character in y should be less than or equal to the frequency of the same character. Okay, if c is present in y also and s also, then frequency of c in y should be less than or equal to frequency of the same character in s. Right? Clear?
हाँ.
For every character c present in a string y, frequency of c of in y should be less than or equal to frequency of c present in s. String Y should be lexicographically smallest among all possible strings obtained by rearranging the characters of Y.
Hmm.
Okay. So find the number of unique beautiful strings as number answer can be huge. Okay.
Yes.
Print its modulo 10 to the power 9 plus 7. Okay.
Hmm.
So lexicographically smallest, there will be only one string, right?
Yes.
Okay, let's see some examples. Find the number of unique beautiful strings as the answer can be okay. Okay. So find the number of unique beautiful strings as the answer can be huge. Print its modulo 10 to the power 9 plus 7.
Yes.
Okay. So let's come to this problem. The first problem. Okay. First example.
Hmm.
So here we have this string ju. Okay. So this is string x. So string x has only two characters. So
Hmm.
string y can also have only at max these two characters only.
Yes.
We can't put any other character in y.
Yes.
That is very much clear because if we put z here, so since z is not present here and it is present in y, its frequency will get greater than its frequency in x. So this won't remain a beautiful string. So we can't take this.
Hmm.
Okay. So next, what else we can choose? Here we can either choose j, we can either choose u, or we can either choose j and u. So these are the three possibilities of beautiful strings
Yes.
we can make.
Hmm.
Clear? Now let's try this example. So here we have a, b, a. So here we have got a two times
Yes.
and b is present one time.
One.
Clear?
Huh.
So what all strings can we make?
A, B,
A, b,
B, A,
a, a,
A, B,
a, b,
A, B,
a,
B.
b. Okay.
हाँ,
So
एक मिनट. हाँ हाँ. हेलो. हाँ स्टार्ट कीजिए.
then were you able to solve this problem? हाँ हाँ भैया. Okay. So here let's continue this discussion. So here this is a simple permutation and combination logic, isn't it?
Yes.
We have got two A's, okay, and one B. Out of these two A, what options do we have?
Can you repeat again?
Okay. So in this problem,
Yes.
you heard the problem statement, right?
Yes, sir.
So here, what we have in this second example, we have got A, B, A as our string X.
Hmm.
Okay. And next here, what all possibilities of string B can we have that we have to print? So here we have got two A characters
Yes.
and one B
B
character.
characters.
So what all strings can we make?
We can make something like B, then A, then AB. Yeah, that. Acha. Then double A, then double AB. Five strings total.
Okay, so what like this was a small string, so you can tell without doing much you can just do different permutation and you can tell. But what's the logic going in here?
So here we can choose something like we can choose A for 0 times and B for 1 time, so that will make B. And we can choose B 0 times and A 1 time, so it will be
Okay,
similar to A.
okay. Let's say we have this string A B C A D B C A B. We have this string. So how will you solve this problem?
So in that case, we'll count the each character, and then so in that case, we'll count how many number of times A is occurring, then B, then C, then D. So there are 4 unique characters. And as per the question, to follow the beautiful string condition, the count of each character should be strictly, I mean, not strictly, less than equals to the count of character in your rearranged string.
Right.
So it will automatically follow the, if you choose between A, B, C, and D, something like that. So it will automatically follows the first condition. So it will always pass.
Mm.
And for the second condition, you have to choose the largest, largest, no, lexicographically smallest string out of them. So, but here we need to print just the number of unique beautiful string. We don't need to print the string. So in that case, we can count the each character, each unique character present in the string. And then for A, like the count of A is 4 and B is occurring 3 times, C is occurring 2 times and D is occurring 2 times also. So, so there are 5 multiplied by 4 multiplied by 3 multiplied by 3 ways to form a unique string, not a duplicate string. And out of them, one string will be an empty string. So you have we have to subtract
Eh,
those strings, uh,
yeah.
subtract that one string from our answer. So that will be the total number of unique beautiful substring that we can form using rearranging the A.
Okay. So here again, coming to this example, A B A. Okay. Here we have got 2A and
B and
1B.
B, 1B. Yes.
Okay. So one thing is for sure that we have to whichever character we are choosing, we have to put, like if we are choosing A, we'll have to put A before any occurrence of B or further alphabets. That's
Yes.
for sure,
Yes.
because we have to make lexicographically smaller
Smallest.
strings.
Yes.
Okay. So this logic is very much clear. Now this permutation becomes like this. First of all, we have to uh, place all the A's. Next up, we have to place all the
The
B's.
B's.
Next up,
Yes.
we'll put all the C's.
Yes.
So on, we'll put all the
D.
Z's. Okay, Z's.
Hmm.
So if any character is not there, that's not our problem. If any character is present, we'll place them in this sequence only.
Hmm.
First of all, we'll place all the A's, then we'll place all the B's, then we'll place all the C's, then like this, we'll place every character. Is it clear?
Yes.
So here we have got 2A. So what are all the possibilities of?
I can choose no A's. I mean, I can only choose B.
Right,
So and then I can choose only a single A, and then I can choose A 2 times.
right. So these are all the possibilities. Either you don't choose anything at all. Like either you don't choose any A, right?
Yes.
Or you choose 1A, or you choose 2A. 0, 1, and
And
2.
2. 3 possibilities.
Right, three possibilities. And with B, what all options do we have? Either we don't choose B,
Yes.
or we choose B.
Yes.
Okay. So what are all the different combinations we'll get? So this is our first string empty. Then next is A. Then next is AA. Okay. Then again I'll make it A. Okay. AA. So we'll put empty string of B first.
Hmm.
Okay. Then next we'll put B string of after A string. Okay. We have got two options here only, right? Here, first of all, we can put empty B or 1B.
1B.
So this is an empty string, right? We can see
Yes.
this is an empty string. This stands
Yeah.
for A. This is
Double A.
double A. This
This
is
is B.
B. This
AB.
is AB.
Double A
And
B.
this is double A
B.
B, right? Same way, we can go for this one also. How many options for A we have here?
No, 5.
5,
0, 1, 2, 3, 4.
right? So either we can choose 0 A's or 1 A. Likewise, we
Hmm.
can choose up to 4 A's because we have 4 A's. So either we don't choose any A at all, or we choose 1A, 2A, or 3A, or 4A, like that. Okay. Now for B, how many options of B, choosing B, do we have?
4.
4. Now coming to uh, C, how many options of choosing C we have?
2.
No,
Oh, sorry, 3. C.
3.
Sorry.
And then coming to D, how many options of
3.
choosing D we have?
Also 3.
Also 3. Now, in one of the cases, we would have chosen every empty string from A to D.
Yes.
That we'll need to subtract. So after multiplying all of
Yes.
these, we'll do -1,
-1.
because that empty string choice which we have made, we need to remove that. Is that clear?
Because yes, yes. Because the question also states ki why cannot be empty, non-empty.
Right.
Why
Right.
have to be non-empty? Yes.
So if this is clear, we for this coding this problem, you'll just need to count frequency of each character.
Hmm.
Like all the characters which you have got, you need to count their frequency, and you will need to multiply. Like frequency of A is, say, x1, so you will need to do x1 plus 1. Then say frequency of B is x2,
Plus
then you
1.
will need to multiply it with x2 plus 1.
Plus 1.
Then say frequency of Z is x26, then you will need to multiply it with x26 plus 1, and you'll need to multiply all of them and then subtract it with -1. And
It will be
then,
a final answer.
right. And one thing which is given in the problem, that these numbers can be extremely large. So what you'll need to do,
Long,
you'll need to
long.
take modulo.
Yeah, long. Yes, modulars.
Uh,
Also,
for
we
those,
need to use long hint also. Otherwise, the first test will be pass and the other 4 tests will fail. So I tried that also.
this is a standard thing, and you should usually use it in your template, like that non thing. Sorry, long thing. So is it clear?
Clear.
Okay. So this is a good probability thing, a probability problem. You should, sorry, not probability, good permutation and combination problem. You should be familiar with these kind of problem, because these kind of problem, rank of word in a dictionary and all, these kind of problems are actually very popular in coding problems, coding interviews, and coding contest. So these simple permutation, use of and or, you all should be definitely aware of these things. Okay. So Chandan, is the question clear? That beautiful string problem?
Yes, clear.
Okay, so now we are moving to this prefixing problem. So again, Tanmay, have you solved this problem?
Yes, भैया.
Okay, that's very good. That's very good. So let's try and solve it again, and let's see if we get some new perspectives. So given an array A of size n, construct an array B of size n such that every element of B is present at least once in A. Is the problem statement clear? Okay, so you are given an array of size A, sorry, A of size n. Construct another array B of the same size as A, which is n only. Clear? Now every element of B is present at least once in A. Okay, is it clear?
Yes, clear.
Every element of B should also be present in A also.
At least one.
Yeah, at least once. So you can't put, like, if a character is if a number is present in A, then only you can put it in B. You cannot put any unique number in B.
Yes.
That's a point to be noted. Now moving to the next condition. Every element in prefix of AI to the last uh, of the A, array A, is present at least once in prefix of B1 to BI. Okay. For every prefix we have to follow, right? For every element prefix we have to follow this statement, this condition. So is this uh, statement, is this condition clear,
Yes.
Chandan?
Yes, clear.
So prefix, I think all of you must be aware about this thing. Like if we have got an array 2, 5, 3, 6, 7. So the prefix array would look something like 2, 7, 10, 16, 23. Okay, the prefix array would look something like this. So every
ये मुझे
element,
समझ में नहीं आया कैसे हुआ 2 7 10 16
we,
23.
we, we are just adding it.
ओके यस ओके हाँ सॉरी.
Okay. So every prefix in A should also be present in prefix of any prefix, same prefix of B. Is it clear?
यस
Okay. So if we are taking up to this element, so this has 2 and 7 in A, so that should also have 2 and 7 in B. Is that clear?
यस
Clear, Tanmay?
Yes, yes.
Okay. If multiple such arrays B exist, find the lexicographically largest B. Okay. Is it clear?
Yeah.
Okay. Let's look at some of the sample problems. Then we'll proceed to solution. Okay, so the examples here are like a bit uh, confusing only, but we can say we can't derive much from them,
Exactly.
right? So here 5, 5, 2, 3. So one array will always exist, which is the same array A only. So what condition we have for B? every element in B should also be there in A
Yes, at least one time.
at least one time.
Yes.
So if this is having array A is having 5, we can also put 5 here. If again array A is having 5, we can again put 5 here. Again array A is having 2, we can put 2 again here. And array is having 3 here, we can also put 3 here. And if we check like in prefix up to first index, their prefix sum is same only, 5 5, so every element is present. Then 10 10, so every element is present. Then 12 12, every element is present till now. Then 15 15, every element is present till now, right?
Yes.
Yes.
So this will always be an answer, but we have to return lexicographically largest answer, which is possible. And lexicographically largest for array, what is lexicographically largest for an array? Like same as we have for strings. The first differentiating integer should be larger for the lexicographically larger array. Suppose we have this array 5 1 6 3, and another array 5 1 3 8. Okay, these are the integers in that array, right? Array 1, this is array 2. So here they both have same integer, no
ये
issue.
एरे 2 कहाँ से आया?
Array 2, I'm just for giving an example for what is lexicographically larger.
ओके.
Okay, so here we have 1, both have 1. Here again we have 6, and here we have 3. So here we got the first difference, and in that first difference, A became larger than B or array 2. So here we can say that array 1 is lexicographically larger than array 2. Is it clear?
Clear.
Yes.
So these are the conditions. First, every element of B is present at least once in A. Second, for all I from 1 to n, every element in prefix AI A1 to I is present at least once in prefix B1 to I. Clear?
Okay.
So how did you approach this problem, Tanmay?
So first of all, the problem statement was seemed to me a bit jarring because the second condition for all I greater than equals to 1 to n, every element in prefix. So that line I didn't understand. So I took a help of ChatGPT. So after that, so ChatGPT gave me a wrong answer, but I understood the problem. So it interprets the problem well, but it gave me a wrong answer ultimately. So
Okay.
it was saying that key. Suppose for that example, can you bit scroll down over here?
Okay.
Hold on a bit. For example, first example, yes. For 5523, so we need to make a array B which is lexicographically larger and also follow the two conditions that were given.
Hmm.
So for the first element of A 5, there is no prefix. So obviously we have to put that in our array B. So so the first element in our array B is 5.
Right.
Then for the second element in our array A, the element is 5 also. But
Mm.
here we need to check if there is any prefix. I mean, if 5 uh, did occur before the second before I mean, if the 5 occurs before that or not. Okay,
Okay.
so
Hmm.
actually it occurs in the first element also, so in the first index also. So in that case we will use we need to make the lexicographically larger b. So we will choose the largest element of our array, which is also happens to be 5.
Hmm.
So in that case we will also put 5 in the second index.
Hmm.
Then for the third index, in A, the element is 2. So now we'll check if 2 occurs before that or not. I mean, if 2 is present in our array A, before
Okay. Okay.
the third
So
index or not.
wait,
Yes,
wait. Let's take a better example so that our audience will be able to understand in a
yes,
better
yes,
way.
yes. Because the examples are also a bit confusing. The for the whole the three examples.
Okay. So this is our updated example. Okay, which we are discussing. So this is array A. This is array B, which we have to make. Okay. So let me repeat the elements here for A. First element is 2, second element is again 2,
Two.
third element is 3, fourth 7, then 8,
Okay.
8, then
Three, two.
3 and 2.
Okay.
Okay. So now how will you solve this?
And so for the first index, the first element is 2. So we'll check before that 2 occurs or not. No, it's the first time, so we'll put 2. So it has no prefix as per the second condition.
Right.
And then for the second index in A,
Hmm.
so we'll check if 2 occurs before that index or not. So it is actually occurring because it is in the first index we have encountered that 2. So then so our goal is to make a lexicographically larger B.
Hmm.
So in that case, we'll choose a number which will help us to make a lexicographically larger B. So we'll choose the largest element present in the A, because that will help us to satisfy the two condition. The first condition is the one element which we will choose the element. I mean what was the first condition? I forgot. Can it is called
First condition, every number in
every element in A should at
every
least,
number in
yes,
B should, right.
occur at least. So in the second index of B, I can choose a element which is greater than 8, something like 10, but it is not present in it. Okay,
Hmm.
so we cannot do that. I mean, for we can choose also infinity, but it is not present, right? So we need to choose an element in that way, a maximum element, so to say, in that
Hmm.
way, which is also present in A. So that's why we are taking the maximum of our array A.
Hmm.
And we also need to make our array B lexicographically larger.
Hmm.
So to fulfill all those conditions, uh, uh, in the second index, we'll put 8.
Okay.
And then in the third index of our array A, uh, the element is 3. So it never occurs before that index. So that means it has no prefix. So we'll simply put 3. Okay. Then in the fourth index also, 7 has never occurred before that index. So it has also no prefix. So we'll put 7 also in the fourth index of our array B. And for the fifth index, the 8 is also never occurred before. So we'll put 8 in the fifth index of our array B. And for the sixth index, the 8 has occurred just before our current index. So in that case, we will take the maximum of our array, which also happens to be 8. So we'll put 8 in the sixth index. And for the seventh index, it is 3. So, and 3 has also occurred before. So we have encountered that 3 in our third index in array B. So in that case, we also put 8 in place of 3. And also same goes for 2 also, because 2 has already occurred 3 times. So we'll also put 8 in the last thing. So
Okay.
it will be our highest.
Right. So here the context of prefix is a bit different than the context of prefixum. Here prefix means, so like we are taking for here we are taking prefix from 2 to 7. Okay, so means every value from this index to this index which is present in A, okay, should occur in B also.
Yes.
Right. So here we have got two twos, right? We have got two twos. So 1 2 we can use, no problem. 1 2 we'll have to keep, but another 2, like if 1 2 is present, right, that means it can verify for another 2 also.
Yes.
Right. So instead of another 2 we can put some another element.
Yes.
Right. That another element can be used to make our array lexicographically larger. And which element can we take there? Which element? We can take the largest element present in our array. Why? Why we have to take largest element present in our array? Why not any other random number? So we have got two conditions here. First condition is we can put only those elements in B which are already present in A. So we cannot put any number in B which is not there in A. That's for sure. Is it clear, Chandan?
Yes.
Yes, clear.
So every element in B should also be there in A. So we have to choose from all the elements in A only. Among all the elements of A, we can choose one element and we can put it here. Now, which element should we choose? Because we have to make lexicographically the largest. So we'll pick the largest element present in array A, which is here 8. So if we put 8 here, okay. So if we choose prefix up to this place, so we have got only one unique character which is 2, which is also present here. Then we don't have any 8, but we have 8 present here. That's a plus point. But we only have 2 up to this prefix, and 2 is present here also in this prefix of B. Now let's move to the next character 3. Okay. So we have got 2, 2 and 3. Okay. And here our second array is 2 8. So do we have 3 up to this prefix?
No.
Chandan,
Yes.
do we have 3 in
हाँ.
sorry, in B, array B?
हाँ.
We don't have any 3 till now. So we'll need to insert a 3 here. So if we insert a 3 here, then we can say that, yeah, we have 2 and 3 as unique element in A till this prefix. And here also till B, we have 2 and 3 and 8 also till this prefix.
Okay.
Now we'll move to 7. So 7, again is not present up to this prefix in B, so we'll need to put 1 7 again. Then 8, 8 is also not present, so we'll put 8. Then again we have 8, so again we'll put 8. Then 3. So 3 is already present in B. We have already inserted one 3. So do we need to insert 3 again?
No.
No, because 3 is already present in the prefix. So
Yes.
instead of 3, what we'll insert here? We'll insert lexicographically largest element present in the array A, which is 8. So we'll insert 8 here. Now again, we have got 2 in array A. So 2 is present already
Yes.
in our prefix. So we don't need to put 2 again.
Yes.
Instead of 2, we can put lexicographically largest element present in the array A, which is
Also 8.
8. Okay. So how do we solve this problem? We can simply, first of all, make a map.
Hmm.
Okay. So map of all the characters of AI, and this will be a running map. Okay. So what we'll do, first of all, we'll take in all the elements of A, then we'll iterate over array A.
Hmm.
Okay. We'll iterate over array A, and what we'll do, we'll check what if this element is already present in map. Map is basically indicator of our prefix array. So have we inserted this element already? If we have inserted this element already in our array, then we'll put largest element present till now in array B,
Hmm.
maximum of array A, sorry. Or if this element is not present till now, if not present, then instead of largest element, we'll put this element. Is it clear?
Yes.
Okay. So if this is clear, then we can code it easily. Instead of storing another array B, we can just simply uh, do the output in the same co only. So that I leave on you because it's not very hard question. All you need is one hash map to solve this problem, and logic is also very much clear. So I'd highly recommend you all to solve this problem on your own.
Okay.
It's the problem statement is a bit confusing if you don't read the example, but if you read the example, then the prefix here is defined below, so which will make your
अच्छा, ऐसा होता है क्या, जैसे कि आप मतलब कि इंटरव्यू में मतलब ये प्रॉब्लम गिवन है, तो इंटरव्यूअर इतना अच्छे से मतलब कि जैसे एक्सप्लेन कर देता है कि हमको ये करना है कि नहीं मतलब।
no, the interviewer won't explain you this much, but if you're not understanding the problem, it's
यस।
your duty to ask intelligent questions so that you get whatever you want.
अच्छा।
Okay, it depends upon
ऐसा।
your
हाँ।
skills that you ask intelligent questions. Okay, so here, okay, I'm thinking like that. So interviewer will think, okay, you are getting the question in the wrong way. I didn't meant this. I didn't mean this. So he'll correct you, or if you are not understanding the problem, you can ask for some sample cases.
ओके।
You can, if you're not understanding a keyword, then you can ask for that keyword. Okay, I'm not getting this specific lexicographically keyword, so
अच्छा।
can you please elaborate on that? I'm not getting this certain keyword. So this all depends upon your skill. He won't explain this much because he has to take a lot of interview, and explaining this much will cost him a lot of energy, so he won't be interested in doing it. So it's your skill. You have to get it out of him. If you're
अच्छा, तो
not
इंटरव्यू में जो आपसे जो क्वेश्चन पूछा गया था वो टोटल न्यू था या मतलब कुछ रिपीटेड थे जो आप पहले कर चुके थे, क्वेश्चन ऐसा था क्या?
uh, most of the time it's not completely unique and it's not completely repeated one.
हाँ।
It's a mixture of already known problem, but not the same problem in most of the cases. Sometimes they directly give problem from lead code, like choose one problem and solve it, but it's not like in most of
नहीं,
the
जैसे
cases.
मैं आज लीड कोड का कॉन्टेस्ट दे रहा था तो उसमें मेरे जैसे कि 3 क्वेश्चन, फर्स्ट 3 क्वेश्चंस था जो मतलब मैं पहले से वो क्वेश्चन कर चुका हूँ एक तरह से, मतलब के डिफरेंट इंटीजर टाइप का स्लाइडिंग विंडो का एक क्वेश्चन आया था तो के डिफरेंट फ्रीक्वेंसी पूछ लिया था, तो उस टाइप का मैं पहले से कर चुका हूँ, तो मुझे लगा कि इसी टाइप का पूछता है क्या। मुझे तो इंटरव्यू का एक्सपीरियंस नहीं है अभी, मतलब पीवीसी का।
Okay, no issues, no issues.
हम्म,
They'll ask you unique problems, and not unique in the sense that it will be completely unique. It will be using some of the already
हम्म,
known facts. Like here in this problem, what will you rate call this problem prefixing? Was this a completely new or already known problem?
हम्म,
Because this kind of problem we continuously solve,
या,
so we can't call them completely new problem.
या,
Okay. Now let's come to another problem here. LCM Mania. So last time also while discussing this Codechef contest, we discussed that these kind of problems, the LCM Mania is the uh, game changer problem. You need to solve this problem. If you get this problem right, there are high chances that you will get selected in whatever interview you are sitting, or whatever coding interview you are sitting, coding round you are sitting, or any coding contest you are giving, you are bound to get a very good rank below 100. This is division 4, but also if you'll see for division 2, I think it should be less only.
या,
Right, in division 2 also only 400 people have solved.
या,
So if you are getting a below 500 rank in division 2,
हम्म,
it's a good achievement. Like a lot of people, like around 10,000, 20,000 people give this contest, and if in those, among those, you are getting top 500 rank, that's a very good rank that you can
हम्म,
boast of. So here around I guess 20 to 30,000 people must have registered for that contest, this contest.
या,
And if you are getting around less than 500 rank, that's a very good rank. So let's try this problem. Tanmay, were you able to solve this problem?
No,
Okay. So one thing, have you given enough time on this problem?
ये क्वेश्चन पढ़ा ही नहीं है वैसे।
That is not a very good thing. Okay, so I'm again repeating this thing. As you give contest, like you were able to solve the first four problems, then for the next problem, like the fifth problem, which you are not able to solve in the contest, you need to give 2 to 3 hours at least on that problem, on understanding that problem, not on solving the problem, but on understanding the problem. When you give 2 to 3 hours on understanding the problem, probably it's a high probability that you will understand the problem, or you will get to verge of understanding that problem. Now, once you understand that problem, you'll need to spend even more time in solving the problem, getting to the solution, dry running different test cases, and then finally coding the solution. This way only you will improve, right? So once the contest is done, then whatever you do post contest defines how will you perform in the next contest. So it's very important to be a good active student after the contest. The more you remain active outside the contest after the contest, the better coder you will become. So again, this is very crucial. So no issues, we'll discuss this. Okay, I'll try to give you some hints, then you try solving this problem. This is a really good problem. These days, uh, both lead code and Codechef are asking good maths problem, and it is one of those problem. Okay. So let's discuss this problem, but from the next classes. So in next class we'll discuss. Next class will be tomorrow only. We'll discuss tomorrow morning's lead code contest. So everyone, please give that contest and please spend enough time on all the four problems. Tomorrow is a weekend. Tomorrow is a Sunday. Wherever you are going, suppose if you are going out somewhere, then also if you are able to solve three question, two question, then keep the third question in your mind whenever and wherever you are going. Okay, and try keep absolving it in your brain. And whenever we discuss it tomorrow in the class, be mindful of whatever thing we are discussing. Then only the flavor of discussions will come. So please try solving every problem from A to D. And if it's very hard problem, I won't recommend. Like if it has got like 100 or 200 solution, you can skip. But if it has got somewhere near to 500 solution submissions, then you'll need to attempt that problem. So let's come to this problem, LCM Mania. So herd gives you an integer n. Find any three integers a, b, c such that n is equal to LCM of a and b, b and c and a. Okay. If there is no such solution, print -1. If there are multiple solution, you can print any of them. So is the problem statement clear? Tanmay?
Yes, to read those test cases, Leo.
Okay. So let's get to this test case 1. So here, if we take all the three numbers as 1, 1 and 1. So LCM of 1 and 1, 1. LCM of these two ones is 1. Again, LCM of these two ones is 1. So if we add these three numbers, what are we getting? 3. 3. So this is the lowest possible sum of three LCMs we can get, right? And what we have to obtain? We have to obtain 1. That is not possible. Is it clear?
Yes.
Now let's come to the next example, which is 6. So 6, how can we obtain 6?
2, 2. LCM of 2, 2 plus LCM 3 type.
2, 2, 2. LCM of these two numbers
Yes.
is 2. LCM of these two number 2. Then LCM of these two number again 2. And if we sum all these three numbers, then what we'll get? 6. So this is one such possible answer. Now 15. How can we get 15? How can we get 15? If we keep 5, 5, 5.
Yes.
Then LCM of these two numbers 5. LCM of these two number 5. LCM of these two numbers is again 5.
5,
Then their sum is also
15.
15. So it is one such possible answer. So one thing which is very much clear to me from this point, if that number is divisible by 3,
Yes.
it will always have a solution.
Yes.
Suppose I have this 21, 7, 7, 7. LCM of these two 7. 7, 7,
7.
7. So if that number which is given is completely divisible by 3, then this problem will have at least one solution for sure.
Yeah.
and that will be the same number repeated three times. Same number by three repeated three times. Is it clear, Tanmay?
Yeah.
Yes, yes.
Now let's take some another big example. Okay. Say we have got 42. So 42, is 42 achievable?
Yes.
Because 42 by 3 is
40.
14. 14, 14, 14.
40.
It's 42. Okay. Let me think of another example.
Here we need to print A, B, and C, right?
Right.
So for the third test case 15, we can divide 15 by 3, so it will be 555. So why is it written 551? I mean that is also a valid answer, but instead of that, can we print 555?
If there are multiple such solution, and you can print any of them.
Acha, so that means I can print 555.
Right. You can print 555. It
Okay.
won't be any problem. So let's take 59. Is it achievable?
No, no.
What about you, Chandan?
No, I think नहीं नहीं हो. मतलब अभी तो जैसे आप बता रहे हैं कि अगर 3 से डिविजिबल है तब अचीव है. आई
No,
नो.
okay, we are not going for 3. Okay, it's probably a bigger number which you won't be able to imagine. Let me give you a simpler example. 11. Can it be obtained in that manner which we are discussing?
Yes. No, no, no. So,
Oh, it is not
yes,
divisible.
1 to 8, I think.
1, 2,
2, 8.
8.
No,
LCM of these two is 8. LCM is these two is 8.
Oh,
8.
sorry. No,
Hmm.
no, no. No. 24.
Two to three. Can I try two to three? Two and two is two. Then two and three will be six. I mean eight. And then two and three. No, this will not be possible. Six, eight, and six. No,
It is becoming 14.
14. Yes, yes. It is not possible, right? If the 2 to 2 is giving the answer 6 and 2 to 3 is giving 14, then it is not possible.
Okay. Chandan.
Yes.
1 2 3. Okay, 1 2 3 will be 2 and then 3. 2 plus 3 plus
One,
1
two,
2 3
3.
1
LCM of these two will be.
2
LCM of these two will be.
6
LCM of 1 and 3 will be.
3. This is a valid answer. This
This
is
is a valid answer. Valid answer.
yes.
Okay. So how we are getting to this condition? Okay, so it's not very tough. It's not very tough. Try applying some basic mathematics like division by some factor, some two, some three, like this kind of thing.
So actually, I was thinking the GCD property about the GCD property, which is GCD of any two elements. I mean, GCD of A comma B multiplied by LCM of A comma B equals to A multiplied by B. So we can write instead of LCM A comma B, A cross B divided by GCD of A by A comma B. So
Hmm.
can we solve that in that way? Impossible.
Try thinking. Like one thing we have derived, if it is perfectly divisible by 3, then
Yes.
we can do it anyhow.
Yes.
The same way, try with some another character, some another integer. Try that way.
Okay. Okay.
See if you can get here, because this problem requires some time. Spend some time, and tomorrow first we'll discuss this problem, then we'll discuss lead codes contest, tomorrow's lead code contest. So again, I'll say that it doesn't matter if you are able to solve even one problem or no problem at all, but you'll need to solve all the four problems, or at least the problems which have more than 500 or around 500 submission in tomorrow's contest. Okay, so let's meet tomorrow to discuss all of these. Okay, thanks. Good night.
Good night.
Thank you.